This question is the repeat of the other mock question on differential equations, and not many people got many marks on this, so it's not been changed very much. All that's happened here is the size of the tank's changed. All the words are the same. So the size of the tank here is now 16 by 8, and it's h high. And so the volume there of this part of the tank is 16 times 8, which is 128, times by h. And when we differentiate that, dv by dh is equal to 128. Now the question doesn't ask us for that. It asks us for dh by dt. So in the reading, it says the rate of change of volume. So the rate of change of volume, that's dv by dt, is inversely proportional to, so fishy, 1 over, inversely proportional to the square root of h, the square root of h. But as we don't like fishies, we get rid of them and replace them with equals, and we change that to a k. We now want to put these two things together to get dh by dt. So chain rule says that the dh needs to be on the top and the dt needs to be on the bottom, h and t, top and bottom. These two things are going to be the same, and the rest of the question has got v's everywhere, so we'll put a v in each of them. dh by dv, that's that one, but upside down, so 1 over 128, times by dv by dt, that's exactly what we've got there, k over root h. When we times these things together, we get k over 128 root h. And because k is just a number and 128 is just a number, we can say this is just some number over root h, like we were asked to show. And this might seem like sort of we're just playing, making things up here, but we could just, if you don't like doing that, you just say lambda equals k over root 128, and then you've got it there. But really, we're just combining these two numbers into one other number. So that's part A. That's the 3 marks for part A. And again, not many people got a lot for part B either. This is a differential equation. So we need to times up the root h up here. You know what? I'm going to write it as h to the power of a half as well, because I know what's coming next, dh. I'm going to put the dt up here, so we get lambda dt. Stick an integral sign in front of both sides. When you integrate h to the power of a half, the power goes up by 1, and we times by the new power. When you integrate lambda dt, you get lambda t plus c. And at this point here, we could times by, we can put the numbers in now, it's perfectly fine. What I was doing when I did this, I actually times by the 3 over 2 now, and so we get a different t plus a different c here. And this is me being cheating like I just did there. There I just made up a new constant. This constant here is just 3 over 2 times that one. It's just another constant. And actually, that's the one that's going to be called A, and that's the one that's going to be called B. So times by 3 over 2. Now we're going to put the numbers in. So at initially, so at t equals 0, they told us initially the height was 1.21. So I've got 1.21 equals, well, 0 times A, so that's just what B is. And then at t equals, they're telling us 6 minutes this time, it's 2.56. So 2.56 to the 3 over 2 equals 6a plus the b value that I'm just about to work out there. Just grab my calculator. So I've literally just tapped those into the calculator here, and I've got 1.31 for A and 553 over 120 for B. So that was 1.331, and I'm going to leave that as a fraction, 553 over 1200. And so my final answer for this part is h to the power of 3 over 2 equals 553 over 1200t plus 1.331. Now, if I didn't times by that number there, we just get the constants, and we've then got to times them by 3 over 2 as well, so it's just an extra step, but not a lot of work to do there. The last part C, says find out how long it takes to be completely full. Now, completely full this time, all the way up to there. This thing was actually 4 meters high this time. In the original test, it was 5 meters high. So I'm going to put a 4 in here. 4 to the power of 3 over 2 equals all of that. And well, I could take that off and then times by 1200 and divide by that. You know what? Even if you wanted to here, you could actually do a shift solve at that point there. And I think it's giving us 14.5 minutes at the end of that. Hopefully you're more successful.